Hi guys, we are doing some examples under sum series and sigma notation. We've done number 1, we just finished number 2, and we're now going to be looking at number 3, number 4, and number 5 in this video. If you haven't watched the previous video, please go watch it and then come back to this one. Okay, so we're expanding that in number 3, we're just expanding. Okay, these are the solutions of the previous problems, but yeah, go watch that video if you want to understand what's going on there. Anyway, so we're expanding the following. It's 9i is equal to 5, 2i. So what you're gonna have here, we're just expanding it, we're writing out what it means. This would just mean that, so you substitute the index there, or the starting value there, and then you increase that by 1, and then you are there, and then you are here, and then you are here, and then lastly you are here. So you've just expanded. You're not calculating it out, you're just expanding it, right? You're expanding it. Whereas in the fourth example, we're expected to evaluate it, right? We're expected to evaluate it, meaning that we should put a value on what it is. This is 2 times 5 plus 2, so they're exactly the same. So we're gonna have exactly what we have up there, but now we are evaluating things here. So if you add all those up, what do you get? Okay, try to calculate it and try to put a value on it, right? So it's just when you evaluate, you just, I'm actually not gonna evaluate it, but yeah, I just wanna, probably it's worth making a note. Yeah, probably now you guys have got the answer to that. It's worth making a note. Here we evaluate, so we actually come with the term, right? We actually come with the term. And then in the other one, we are just, so the term here, when we're evaluating, is actually 70. And here we are just, what's the word again? Expanding. We are just expanding. Right. Now, a lot of people have seen problems that look horrible. Someone can be like, evaluate. I'm just putting this problem just here and leaving it. They could be like, evaluate the following. Then they can say, 9i is equal to 5, 2i. And then they can say minus 2i, 9i is equal to 1. Oh, sorry, now I is equal to 7. You evaluate this alone, and you evaluate this alone, and then you just subtract them. So those things shouldn't be difficult. Okay, anyway, I'll get rid of that. I just wanted to give you guys a sense of how things could look like, or what you think could be difficult, but it's simply just an application of what we just did. Okay, lastly, number 5. In number 5, we need to write 1 plus 4 plus 7 plus 58. We need to write that in sigma notation. Now, in the previous videos, you've seen how to write things in sigma notation. First of all, you just write, that. That's the first thing that you do. And you just say, you can start at I if you want. You can say I is equal to 1. You can write that. Now, what you're going to have to do here is to find Tn. Right. It's to find Tn. So I'll put maybe let me put this is our sigma. So let's try to find Tn. So 4 minus 1 is 3, 7 minus 4 is 3. So we can already find that we know that our A is 1, and now we just found our D is 3. Right? Do you see this one? The D is 3. But if I was getting something else here, maybe 4, I was gonna go check if it's, you see now what I did, I first checked if it's arithmetic, and then use the arithmetic for Tn. But it could be that it's geometric. If it's geometric, I'm gonna get funny numbers here. Then I have to try to check for a constant ratio, right? And then my Tn will take the form of a constant ratio if I have confirmed that this is a geometric series. But again, we're not necessarily focusing on, this is just you finding Tn, and we know how to find Tn of any other pattern, of most of the patterns that we've looked at, geometric, quadratic, and arithmetic. Anyway, so going here, this would be Tn is equal to A plus n minus 1. Then we're going to get a D there. That's going to be 1 plus, n minus 1, and then we're just going to have a 3 there, and that's just going to be 3n negative 2. Please go take a look at that. Try to do it yourself to be content about that. That's your first step. Remember, you just write that. That's your first step. Your second step is that you write the Tn. So this is us writing the Tn over here. The third step, you actually find the end value. You find what's happening here. So how do you do that? So you say your Tn must be equal to your last number, right? There are notes where I talk about how to find sigma. This is just an example on using those notes. So now we know that 48 would be equal to our Tn, which is 3n minus 2. That would give us 47 is equal to 3n. Right. And then, this is a bit weird. It looks like I have made a mistake somewhere. Okay, I'm just looking at my mistake. If you can spot my mistake, let me know. That's 3n, that's minus 3, and if I add 1 there, oh yes, my Tn is not 45, it's 58. Thank you, that is 58. So if that's 58, we'll have 60 over here, and then our n is going to be 60 divided by 3, which is 20. Right. So how did I okay, maybe let me just finish this, and then we gonna get 20, I is equal to 1, I is equal to 1, and I've made another mistake here. If this is I, this must be in terms of I as well, right? So that cannot be n. I know I found it in n because that's how I know how, but when you're writing it back, if you chose your index to be I, that must be I, like that. Okay, I am happy, everything is correct. How did I see that I made a mistake here from this side? I saw because my n was gonna be 50, no, it was about 47 over 3. That's not a natural number. Remember, our n must always be the element of natural numbers. So yes, that's how I saw that I've made a mistake there. But everything is well, and we are done with our set of examples. I'm likely to go on to another section. Okay, I'll see you guys in the next video.